Welcome to today's Dlubal webinar. Today you will learn how to perform a warping torsion analysis and design utilizing the plastic limits. My name is Gerlin Schubert. I am the moderator today, and my colleague Wieland Götzler is the presenter. He will show you an example in RStab. Sebastian, he will answer all your questions during the webinar using the live chat. Both Wieland and Sebastian are responsible for the steel add-on modules of RFM and RStab, and also of the steel joints modules. We get started with the concept of the that's just a control panel. So this is the important bit down here. You can use the chat options to ask your questions. So, and Sebastian will try to answer all your questions during the webinar, and just in case there are too many questions coming in, you will get an answer, but it might be via email tomorrow. And you can show and hide the control panel using the orange button up here. We get started with the concept of the RF steel module EC3 and its module extensions. I will then summarize a few features of the RF steel warping torsion add-on module and the RF steel plasticity module. Then it's time for me to hand over the screen to Wieland, and he will show you an example in RStab, and he will perform a stability design checks using the second order analysis and employing 7 degrees of freedom. He will also perform a plastic design in RF plasticity. Okay, let's get started with the concept. We have the add-on module RF Steel Eurocode 3, RF Steel EC3. Here you can design it in accordance to the Eurocode 3. You can perform stability design checks. You can do deformation analysis, and of course you can also do some fire protection analysis. And together with this add-on module, you can enable 2 different extensions, and one is the RF steel warping torsion. Here you perform a design with the second order analysis under consideration of a 7th degree of freedom. That's warping torsion. And a second extension is RF steel plasticity. Here you can perform a plastic design of cross sections. Both are shown. They are both working either independent or you can use them in combination. And Wieland will all show you this throughout the example. To give you a bit more detail, here's a list of features available, and these are the features of the warping torsion extension. So you have a standalone solver, and this is considering 7 degrees of freedom. So the 7th degree is the warping torsion degree of freedom, beside the usual translational and rotational degrees of freedom. And it is performing a nonlinear analysis in accordance to the second order. You can enter imperfections, and in general this extension is available for thin-walled steel cross-sections. The RF steel plasticity, we have different methods of analysis available here. The main one is the partial internal force method by Kindman and Frickel, and this method is suitable for nearly all types of cross-sections. This method exists with and without a redistribution of internal forces, and a second method that is available is the simplex method. This is for general cross-sections, and another type is the analytical nonlinear optimization procedure, which is used for elliptical cross-sections. So it's now time already to hand the screen over to Wieland. He will show you all the discussed things live in RStab, and just a side note, everything that is shown and discussed today is available in RStab and RFM. So the add-on modules shown today are available for both program families. So now I hand the screen over and enjoy the webinar.
So, thank you for the introduction, Gerlin. Now it's time for the live presentation of this webinar, and I have already prepared the model to start with the steel EC3 design. So you can see we have a very simple frame with a vertical and horizontal loading, just one load case, and I want to take a look at the horizontal beams which we want to design as a set of member. So there's not just one single beam, it is divided by one node, so I had to prepare a set of member to use it as one element in the steel EC3 design. Because some of you might see this module EC3 for the first time, we're going to start with just a basic design of according to Eurocode 3, and then we want to do a upgrade, let's say upgrade to warping torsion and plasticity later in this presentation. Yeah, so I've opened the module steel EC3. I have to select the load case which I want to design, which is the only one, LC1. I want to check my set of member, and today we want to design according to the sen variables in Eurocode 3. In the first part of this design, I want to check this set of member not according to the general method. I want to design it according to the equivalent member method, which I can change in the stability dialog of details. Then I can continue to the next mask to check the material again, which is S235. This is fine. Cross-section is IPE 500 section. I have no intermediate restraints on this horizontal beams, so I can skip this mask. Otherwise, you can prepare intermediate supports along this beam as you wish. In the next mask, which is effective lengths, you can define all the settings for buckling about y-axis, buckling about z-axis, and lateral torsional buckling in these columns. We want to keep it simple and design it as a simple fork-supported set of members. So all of these settings are already fine. We have buckling lengths factors of 1.0 in both directions, and the beam is simply fork-supported. So now I can just run the calculation, and you will see we have a overloaded horizontal beam, horizontal set of member here. We have a cross-section class 3, and you can check all the partial results in the design table on the bottom. So you have a part of the cross-section classification. You can see the critical buckling loads over there, and you can check, let's say, almost every intermediate results in this table. You can export it, and also you can take a look in the graphic to check the results. So there we have a class 3 section. I think this is at the X place where there's no bending moment. Yes, so we have only compression force, and that's why the IPE section is applied to class 3. Let's get back to the design module. If you want to check the eigenvalue solver, which is inside this module, to get the critical bending moment, M critical, over there, you can check this button here, mode shapes, and you can see that there we have a lateral torsional buckling eigenvalue or eigenmode. And now it's the question, how can I design this structure, or how can I stabilize it? And therefore you have several options. As I've said, you can place intermediate restraints as you wish, or in this example I want to show you the rotation restraint or the shear panel. For this example I will take the rotational restraint, and therefore you can change to the component description over there. And we want to take a trapeze sheet into account, which I can easily pick from the database. Let's say this is a Fisher trapeze sheet, 85 to 280 1.25 thickness. That's fine. Okay. And the module will take into account all these values automatically. You just have to define a beam spacing, and maybe you want to change the C100 value according to Eurocode 3 part 1.3. Okay, I want to have a beam spacing of 5 meters, and then I can run the calculation again, and now you can see that this structure is already stabilized. We have a fulfilled design, and this is fine. You can also check the partial results of the rotation restraint over there up to the total rotational spring stiffness. All right. In the next step, I want to do a small change in the structure because I need some more spacing on the connection of the beam to the column. I want to prepare a taper at the beginning and at the end of the beam. Therefore, I just right-click on the member, edit member, right-click, divide member by distance, and I can easily change this value to 1 meter and this one to the same, divide member by distance at the end, 1 meter. To define the taper, I can just change the cross-section at the beginning, IPE 600 now, and IPE 500 at the end, and the program will automatically define the taper over there. Same thing on the right side, not at the column, on the beam. IPE 600 section on the end, at the end of the beam. Now I want to run the design again. The question is now in the first design, we had a design according equivalent member method. We had bending and compression, and this is according 6.33 chapter of Eurocode 3. And this chapter is only valid for uniform members. Now we have a tapered member, and we have to change this one because it's not valid anymore. If you have a taper, you can use the general method. Click on OK, and you will see for the set of member, it changed the look automatically to nodal supports. And this is a different method from the last one. It's not equivalent member method. General member method means you have a design according to chapter 634 Eurocode 3, and therefore we have to place some nodal supports to get the, let's say, equivalent system for the eigenvalue. You can check these nodal supports graphically in this view. As you can see, we have the whole frame over there, but by clicking on local coordinate system, you can change to view the nodal supports, and you can check them. But in my example, these default nodal supports are already fine, and I can just design this set of member by clicking on calculate. So also for the tapered member, we have a design according 634 general method, which looks a bit different, but it's basically, as you can see, there's a small issue with the graphic there, but as you can see, this is also possible to have a design for tapered set of members. Now we have to follow a more specific problem of the structure. We want not just to define the transverse loading and the horizontal loading, we also want to take some cross-bending into account, and therefore I right-click on General Data, change the structure to 3D, have to define some nodal supports to support the frame out of plane. And therefore I can just define the loading out of plane, which is 10 kilonewton in this example, in the center of this horizontal beam, which is quite a bad loading in this position, but we will see how to define it, how to design it. First of all, we want to try to do the same analysis again, just by running the calculation again. But there's a warning message coming up, which says that there's a moment about the z-axis, of course, and this is not allowed for this design method. Yeah, the design according to chapter 634 allows only a loading in plane, and this bending moment mz is due to a loading out of plane. And now we come to the problem where you probably need this new module warping torsion, because the question is now how to get this design done for this loading and this model. And there's one really easy solution in Steel EC3 now with this new module warping torsion. You can see over there we have quite a lot of cross-bending with about 36% of the resistance and plastic. So we cannot say, okay, I want to neglect, let's say, 10% of the cross-bending over there. This is not a solution. The warning message will pop up anyway, and the question is, no, we cannot say, okay, I want to neglect the 36%. We have to take it into account, and therefore I will just activate this new module, Steel Warping Torsion. In details, warping torsion, you can do this one. Over there, just activate the checkbox. Okay. Now we can switch to the nodal supports again. And it's basically the same as in general method, but you can see that now we have not just 4 columns with 4 degrees of freedom for out-of-plane stability problems. We have all 7 degrees of freedom. That means all the deformations, all the 3 rotations, and the 7th degree of freedom, the warping. We have to check the boundary conditions again, which is fine in this example, I think. Let me just remove the deformation in local x-axis. And now what we want to do with this module is we want to perform a stability design not with the equivalent member method or with reduction factors XZ, XLT, and so on. We want to do a second order stress design, and there's a last question coming up now, and this is how to define the imperfection. Because for a second order analysis you need to define this one, and this is done by applying this initial bow imperfection according to the first to the eigenvalue or eigenmode of the structure. Let's say in this example we want to do the design according to L 250th of the length of this eigenshape. And this is the value you will find in the national annex of the Eurocode. So in Germany there's for example, there's a table where you can find this value which says, okay, you have H to B of the section bigger or smaller than 2, and you will find exactly this L to 200th, L to 150th, and so on in the table. And after we've defined this initial bow imperfection, we can simply run the design again, and now you can see there's no warning message coming up, but it's, let's say, slightly overloaded by over 50%. Now we are about around 146%. And in the bottom you can see we have the rotational spring stiffness taken into account. We have a section 1 now, section class 1, and there's a critical load factor of 2, which seems fine. The checking of the initial bow imperfection, and in the bottom of this table there's all the stress design. Yeah, you can see all the partial ratios due to normal force, due to bending moment, and so on, until you get the full design formula according to equivalent stress. You can check it also in the graphic. This is the section classification, which is fine, but now we have just elastic stress design, so it doesn't matter if you have a section class 1 or 3. You can check the internal forces of this new calculation up to the bending moment and so on. And you can check all the stresses from normal stresses to equivalent stress in this tree on the left side. So what this module is giving you is the opportunity to check all the critical cases in EC3 which you cannot design before. That means, as you can see, we have a bending around the weak axis on the tapered section, which is not possible to design according to equivalent member method. You can have a general cross-section, maybe from our cross-section program shaped thin, which you cannot design before that. All these cases which might lead to a warning hint, undesignable, these are possible to design now with warping torsion. To give you a better chance to get a better design, the next additional module, there's another upgrade called Steel Plasticity. This might help you to improve this design over there. Yeah, now we have about 150% loading, and we want to check if there's a possibility to get this design fulfilled somehow. And as I've said, we have this class 1 section, which is fine, but we only have an elastic stress design in warping torsion. So what we want to take into account is the plastic resistance of the cross-section, and this is what we can do with the module Steel Plasticity. So I want to activate this additional part of EC3 module over there, and you can decide if you want to do a check for all the cross-section classes or only for class 1 and 2. And you can check also general sections like shaped thin sections, C, Z sections, whatever. You can choose the simplex method for these sections. Okay, and you don't have to do anything else because in details warping torsion, this is still active, so we will use the warping torsion internal forces to get the design done with the plastic resistance of the cross-section according to partial internal force method. And just by clicking on calculation, you can see that this design is now fulfilled. Yeah, we have a plastic resistance of the section, and with the partial internal force method, it was possible to get this design done. And this is quite a nice feature. So you can, yeah, now also the eigenshape is working again, this graphic, and of course we still have a lateral torsional buckling eigenshape, but now it was possible to get this design done with the aid of warping torsion to get the second order internal forces, with the aid of imperfections, and with the module extension plasticity. So let me just summarize a bit. The EC3 module gives you a lot of opportunities to get all the designs done for all the sections which are mentioned in EC3 code and all the loading which is mentioned in EC3 code. That means all the I sections, all hollow sections, and bending around all the axis and normal forces are not a problem in EC3 module. If you have a bending moment around the Z-axis, if you have torsion, which is a big topic, if you have unsymmetric sections, shaped thin sections, all the general sections, and you have a loading with bending and compression, you might need warping torsion, and this gives you a solution to get the steel stability design done all in this module. And to get even the plastic resistance of the cross-section and take this into account for this second degree of second order analysis, you can choose also steel plasticity. And with this, I've coming to the end of this presentation and want to hand over to my colleague Galen Schubert again. I'm really looking forward to get all of your questions and try this module. We are very happy to get a feedback of you, and yeah, thank you very much.
Many thanks, Wieland, for the very interesting webinar. You also summarized the advantages very well at the end. With the Warping Torsion extension, you are able to design cross-sections that were non-designable beforehand. And with the Plasticity extension, you are able to use the plastic resistance limits. If you are interested in these add-on module EC3 and the extensions, please download the trial version. You find all the information on our website. I just quickly show you this. So if you go to our website, it's dlubal.com. You find under downloads and infos, you get the free trial versions, so you can download free trial versions that are working. These are full versions, valid for 30 days. And if you are already an existing customer and using RFM and RStab already, just give us a call. We can easily provide you test licenses for those add-on modules. When you need some more background information, there are always previous webinars available. We record all of them, and you find this information also on the website. Below news and events, you find the webinars, and here's a long list of recorded webinars. And if you just search, for example, for steel, you get a list of all related webinars for steel. So I want to emphasize two of them, which is the structural analysis of steel structures, and analyzing steel joints might be interesting for you as well. So for our American and Canadian customers, do not forget to request your PDH credit. Just write an email to info.us@dlubal.com. And last, I want to invite you to the upcoming fair trade, which is the BAU in Munich. This event takes place in January next year, and we are present, and you could talk to us personally. Many thanks for your attention. I just double check if all questions are answered. Okay, it seems to be the case. So I thank you very much for your attention. I hope you enjoyed the webinar, and I hope to welcome you again. Goodbye.